Lesson 8.5, Part B. We worked on solving an equation by completing the square when a was equal to 1. Now we're going to take a look at the case where a is not equal to 1. In this case it's equal to 3. And how do you handle that type of situation? Well, you cannot complete the square unless that's a 1. So we have to add in a step that will take care of that. Now, to make this a 1, we're going to divide everything by 3, both sides of the equation, because it's an equation and must remain balanced, therefore the same thing must occur on both sides of the equation. If I divide by 3, I will get x squared minus 3x minus 1 equals 7. Now I can go ahead and factor this by completing the square. So if we remember our steps, as is, this trinomial cannot be factored so that you have a complete square, or a perfect square rather. So we're going to add 1 to both sides. The constant is going to move over to the other side, as our table suggests. When we do that, we have x squared minus 3x. We're going to add something new. On the right side, that becomes an 8, and we're going to add something new to both sides. What is that number? Well, if you remember the process, we're supposed to take half of the b term and square it. Well, we're looking at this right now. Okay, so half of the b term. Well, the b is a 3 or a negative 3, and I haven't been worrying about the signs, and neither should you. And then we square it. Now, there's one thing we want to try and do here, and that is stay away from decimals. So if I write 1/2 of 3, I'm going to write it this way, 3 over 2. And then I'm going to square it. Again, stay away from decimals. I know it's an improper fraction, and that's okay. If we square this, if we remember our rules for exponents, the numerator gets squared, and so does the denominator. And that is our number that will allow us to complete the square. Now it looks like a fraction, and it is. It looks improper, and it is. It looks like it's a big old mess, and it may seem like that. But keeping it in fraction form will actually make this problem a little bit simpler. Okay, so bear with me. So I want to add 9/4 to both sides. Alright, and on the left side it is now factorable. X, and factors of 9/4 that add up to a negative 3. Now that sounds really crazy. And how would that work? But let's look at a couple observations. When we have it factored, how does this number here and this number relate to this number? It's half. Okay, if I go to a previous example, let's see if that holds true. This number and this number are half of that number. Okay, so let's go back to our current problem. And make the observation. This term and this term will be half of 3. Well, we've already done that. Half of 3 is 3/2. Again, not a decimal. Let's just write it in as is. So I'm going to say minus 3/2, minus 3/2, and that's good enough. So just because we have a fraction in there doesn't mean it has to be more complicated. Keep our thoughts clear and simple. What is that number? It's half of our b term. So on the left side, we can actually write this as x minus 3/2 quantity squared equals. And on the right side, we're going to want to put this together. Okay, so 8 plus 9/4. Now if you remember how to do that, 8 plus 9/4 is the same as 8 and 9/4. And that's a mixed fraction. So let's make it an even more improper fraction. 8 times 4 plus 9, and we have 41/4. So let's write that as, on the right side then, 41/4. Now how did I do that again? Remember, you can take a mixed number and make it improper. It's already improper here, but it's considered a mixed because we have a number out front of the fraction. We take 4 times 8 and add the numerator. So denominator times the front number, add to the numerator, gives you the mixed form of that fraction. So now we have a number, or a problem where we would square root both sides, and we get x minus 3/2 equals plus minus the square root of 41/4. Okay, so that gives, then I'm going to add 3/2, and we get x equals 3/2 plus or minus the square root of 41/4. Now we can go to decimals. 1.5 plus or minus the square root of 41/4. If I type that in my calculator, I get 3.202. Okay, now we would then again remember that that represents two scenarios. It represents x equals 1.5 plus 3.202 and x equals 1.5 minus 3.202. And it gives us two possible answers, so 1.5 plus 3.202, which is 4.702, and 1.5 minus 3.202, and 1.5 minus 3.202 is negative 1.702. And there's our two answers. So this one was more complex because you had an a that was not 1. It happened to be that when you divided and you got divided by 3, you got a number that was not even. So when you divided by 2, you got a fraction. Okay? But we could still do it. We could still do it. This is probably the most complex of a question that you would see because of the fractions, but it is still possible. So maintain your consistency through the table to help you through it all. And that ends Lesson 8.5, Part B.